Number 43. For the following exercises, graph the polynomial functions. Note x and y intercepts, multiplicity, and end behavior. So when they tell you this, I'm assuming they mean to do it the old-fashioned way by hand, right? I don't think you'd get much out of this if you just punch this into your technology. So, and there is part of the book that's devoted to graphing these by hand. And so let's take a look at this one. We've got g of x equals x plus 4 quantity times the quantity x minus 1 squared. Okay, now if you look on page 247 in your book, and we're also going to be using page 244, the information there later on when we graph these. And I think that's it. All right. So if I were you, I'd print these out and use those as study guides, all right, when you are preparing for a test, perhaps. So these give you what you need to know to graph these by hand. All right. So on page 247, it gives you a step-by-step procedure for graphing these functions. So if you look on that page, you'll see the first step is to find the intercepts. All right. So let's look at the x-intercept. If you set that equal to 0 and solve, you're going to get x equals negative 4, multiplicity 1. And yes, the multiplicities will be relevant later when we graph this, so keep track of the multiplicities. All right, you'll need that information later on. And we also have one multiplicity 2. I'm not going to go over the details of getting the intercepts because you should know how to do this one by now. We've been doing those in detail before this. All right. So if you don't know how to find the intercepts on this, go back a few problems, and we've done a lot of those in detail. All right. So what we have then is negative 4, 0. That's an x-intercept, and 1, 0. Okay, and then y-intercept. That's that would be just g of 0. All right, g of 0 equals 4. So we have the point 0, 4 as a y-intercept. Okay, now number 2, step 2, we check for symmetry. Why? Because if the graph has symmetry, then you just need to draw part of it, and then the rest of it can be drawn just by using the symmetry. All right, so is it even or odd? In other words, if it's an even function, it's symmetric with respect to the y-axis, and if it's odd, it's symmetric with respect to the origin. So there's a test for this. You take g of negative x, and that equals, if that equals g of x, it's an even function. If it's equal to negative g of x, it's an odd function. All right, so let's see what happens. Plug in x equals negative, negative x here and here. Alright, plug in negative x for x. So that would be negative x plus 4, and then negative x minus 1 quantity squared. So that's, well, what does that equal? This could be changed to an x plus 1. Let me show you how. It really isn't going to show us anything here much, but it's a good trick to remember. You factor out a negative 1 from these two terms, so put that in front. That leaves you with an x plus 1, and you're squaring all of that, okay? And then you square the negative 1, and then you've got the x plus 1 that's being squared. Alright, so this is two factors being squared, so you could put the power on each factor. Alright, that's xy squared equals x squared y squared. Okay, that's one of the properties that you should know already. Negative 1 squared is just positive 1, so what you have left is just x plus 1 quantity squared. Okay, so you could write that as x plus 1 quantity squared, but it's not really going to help much here, because we can see that it does not equal g of x or negative g of x. Alright. So it's not symmetric with respect to the origin or the y-axis. Okay. Okay, now I'm going to need to erase here to get some more room. So hold on to your horses. Alright, step 3. So we're going to use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercepts. Alright, I'm going to write this out, but I'm not going to write it all out for any further problem. I'll just leave you to look at the book on page 247. Use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercepts. In other words, does it bounce off at the x-intercept, or does it go all the way through, straight through, so to speak? Okay, so now this is something you find out on page 244, okay? 244. So we have one x-intercept, negative 4, multiplicity 1, which we already found. Okay, so the graph will cross the x-axis at x equals negative 4. It goes all the way through, alright? It doesn't bounce off. It will cross the x-axis. That's because odd multiplicity. Multiplicity 1 is odd. Alright? Odd multiplicity. Alright? Now we have one multiplicity 2, another x-intercept, multiplicity 2. and the graph will touch. In other words, it'll touch and bounce off, so to speak. Okay, so we'll touch x-axis. Alright, so that's because at this point x equals 1. That's where it'll do that. And that's because it has even multiplicity. 2 is even, of course. Alright. Alright, so now the next step, number 4. Determine the end behavior by examining the leading term. Alright, determine end behavior by examining leading term. Okay, now if you multiply all this out, alright, you're going to get an x squared, and then times x gives you x cubed. So the leading term is x cubed. Alright, so we need to determine, or rather examine that. Okay, so here we go. As x goes to negative infinity, g of x goes to negative infinity. Alright, you just plug in negative numbers and keep going to the left as you go to negative infinity. This is still negative when you cube it. Alright, so that's going to negative infinity, the whole function. And as x goes to positive infinity, g of x goes to positive infinity. So there's our end behavior. Okay, so number 5, use the end behavior and the behavior at the intercepts to sketch a graph. So this is going to be a rough sketch. It doesn't have to be exact. I'm not even going to put many coordinates on there. We don't need that many, and it's going to look terrible when I graph this, but the idea is to get a general picture of what this graph looks like. All right, it doesn't have to be super accurate like a computer would draw it. Okay, so I'm going to need to erase this once again and draw my rough sketch. So just hold on a sec. So here we go. Okay, here's a rough sketch. X and Y axes. Okay, and we want to draw our x-intercepts. There's x equals -4. We know that's one of the intercepts. And we know that it crosses here. We've already determined that, so I'm just going to write that there, cross. Okay, at -4. I'll put a dot there for now. And at y equals 4, we know it crosses there. That's the y-intercept. And then at 1, x equals 1, we know it's an x-intercept, but it just touches here. And then for the end behavior, as x goes to the left, g of x goes to negative infinity, so I'll just draw that little arrow like that, showing a general tendency of the function. And as x goes to the right, g of x goes to positive infinity, so something like this. Alright? So way out here, we know that g of x is below the x-axis. It's going to negative infinity. Where does it start to become positive? Up here, right there. It goes through that. It crosses through there. So it's going to look something like this. Go through. Now, how high do we go? We know it's going to go up, and then it's got to come back down and touch here, right? So it's going to go through here when it's coming back down. How high do we go up? Well, let's take a point like right here, -2, and see what g of -2 is. Okay, g of -2 equals 18, right? So it's going off my graph, all right? But I'll just draw it, like I said, very rough sketch, all right? This is not accurate at all, all right? But here's a general shape. It's going to go up, and around around x equals -2, it's going to start to flatten and then go down. And then it's going to go down through the y-intercept there. And then it's got to come down and touch here, right there. And it bounces off, so to speak, and then it's going to go up, all right? So that's a terrible graph, but hey, that's better than a blank sheet of paper, right? So that kind of gives us a general idea of what the graph looks like. Okay. Now, step 6. Ensure that the number of turning points does not exceed one less than the degree of the polynomial. Alright, so that was one of the properties that we covered before. So the degree of g of x equals 3. Alright, and there are 2 turning points. One right here, 1, 2. So yeah, it's okay. So that's okay. And then optionally use technology to check the graph. And so I definitely did that. I used my computer to graph this thing, and here's what it looks like. It should look kind of like what we drew here. And if it does, then you can breathe a sigh of relief. Alright, so I'm relieved. Otherwise, you'd have to go back all over it again and see where you made a mistake. Alright, so I put some of the details on there for you. And yeah, that looks like what we expected. Okay, number 45, we have k of x equals the quantity x minus 3 cubed times the quantity x minus 2 squared. Okay, so step 1, find the intercepts. Alright, so we've got X-intercepts. We've got 3 multiplicity 3. And we have 2 multiplicity 2. Alright, so that would be 3, 0 and 2, 0. The y-intercept, that's, okay, y-intercept, there we go. Alright, so k of 0, that's going to equal 0 minus 3 quantity cubed times 0 minus 2 quantity squared. And so that equals negative 3 cubed, negative 2 squared. That equals negative 27 times 4. And finally we get negative 108. So we have the point 0, negative 108. Step 2, check for symmetry. Alright, so whether it's an even or odd function. So take k of negative x. See if it equals k of x or negative k of x. Alright, so k of negative x is equal to negative x minus 3 cubed, negative x minus 2 squared. And so we can factor a negative 1 out of these two terms and inside the parentheses, so I'm going to do that here. Like that. You could do the same thing here. So that equals negative 1 cubed times x plus 3 quantity cubed. Alright, negative 1 cubed is still negative 1, so you're just going to get this. And then you're here, negative 1 squared is 1, then you've got the x plus 2 quantity squared. Alright, however, that does not equal k of x, nor does it equal the negative of k of x. Okay, so that means it's not symmetric. With respect to either the y-axis or the origin. Alright, once again I'll need to erase. So, on to erasing. So, step 3, here we go. Use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercepts. So, again from page 244. So we have 3 multiplicity 3. What does it do at x equals 3? It crosses because of odd multiplicity. Multiplicity is 3, so it's odd, so cross here. And we have 2 multiplicity 2. So at x equals 2, the graph just touches it, or bounces off there. So touch. That's because of even multiplicity. Alright. So step 4. Determine end behavior. So the leading term, when you multiply all this out, you're going to get an x cubed times an x squared is x to the 3 plus 2 equals x to the 5th. Alright, so the leading term is x to the 5th. Okay. So as x goes to negative infinity, k of x goes to negative infinity. And as x goes to positive infinity, k of x goes to positive infinity. All right? And number 5, step 5, we're going to use all this information and draw a rough sketch. So here we go. So what do we have? We've got intercepts at 2 and at 3. That's x equals 2 and 3. And we have a y-intercept way, way, way down. I'm not going to worry about how far down it is. I just put it right there. There's your y-intercept. That's at negative 108. Okay. And here, let's see, at 2 it touches. I'll just put a T there. Touch, and here it crosses at 3. I'll put a C there. Alright. And end behavior, as x goes to the left, g of x goes down. As x goes to the right, g of x goes up. Alright. So it's down here, and it's coming, and it's going through there. Alright, so let me draw it like that. And it's going to just touch there. And then, what is it going to do? It does something like this. If you want to, take k of 2.5 and see what you get. You should get a negative result, alright? So it's bouncing off anyway, so it's going to bounce down, but it's got to go back up, alright? And it's got to go through at x equals 3, and it keeps going up like that. So it's going to look something like that, alright? Okay. And then, what do we have next? Ensure that the number of turning points does not equal 1 less than the degree of the polynomial. Okay, the degree is 5. How many turning points are there? 1, 2. Alright, here and here. So, yeah, 2 does not exceed the degree of 5. 2 is not 1 less than the degree of 5. Okay, so does not exceed 1 less. Alright, so it's fine. It's okay. So now we can actually use a computer technology or something, graph this thing. And here we go. Here's the result that I got with all the information. See if I can get this all in the screen. Number 47. We have n of x equal to negative 3x times quantity x plus 2 times quantity x minus 4. Okay, so step 1, X-Intercepts. Alright, so we have 0 multiplicity 1. We have -2 multiplicity 1. And 4 multiplicity 1. So that would be 0, 0, -2, 0, and 4, 0. And then y-intercept, n of 0. Well, it's easy. When x equals 0 right there, no matter what these two are, 0 times everything else, including the -3, 0 times all of that is going to be 0. So it's very simple in this one. N of 0 is 0, so the y-intercept and the x-intercept are the same. Okay. Symmetry, step 2. So take n of -x. That equals -3 times -x, and then times -x plus 2 times -x minus 4. So negative times negative is positive, so that's positive 3x. And then we've got the -x plus 2. And we can factor out a -1 from these two terms. Like that. We're not squaring it or anything, so it's just power 1 there, so you can bring that out in front. The negative, that is. Think of that as being a -1 multiplying, and you can use commutativity of multiplication and bring it over here and put it right in front, so it becomes -3x, -x plus 2, x plus 4, like that. Okay. Well, that doesn't equal n of x or -n of x. Alright, so it's neither even nor odd. So it's not symmetric with respect to the y-axis or the origin. Alright. Number 3, use the, step 3 rather, use the multiplicities of the zeros to determine the behavior of the polynomial at the x-intercepts. So all the zeros have multiplicity 1, so the graph crosses at every intercept, x-intercept that is, crosses at every x-intercept. Okay? So step 4, and behavior. Okay, the leading term, you've got a -3x, and then x times x is x squared. -3x times x squared is -3x cubed. Alright, that's your leading term. So as x goes to -infinity, n of x goes to +infinity. So you put in negative numbers as you go to the left on the x-axis. You're going to have negative times negative. See, the negative is raised to a power 3, which still is negative. So you're going to have negative times negative is positive. All right. So as x goes to -infinity, n of x, the function will go to +infinity. And as x goes to +infinity, put in positive numbers in here, cube them, they're still positive. Multiply that by -3, it's going to become negative. Alright, so n of x goes to -infinity. Alright, so step 5, use all this information to get a rough sketch. Okay, so here we go. So we have the intercepts. We've got a -2, 0. We've got 0, 0. And we've got 4, 0. Okay. And the end behavior, it's as x goes to the left, n of x is going up. Alright, so here, as x goes to the right, n of x is going down. So like that. Okay. So, and it crosses each of these intercepts here. So it's coming from way up here, and it's coming down, down, down. Alright. And it's going to cross there. Okay, now in order for it to go through here, it has to go up. So it's going to do this. In order for it to go through there, it's got to go down. Alright, there you go. That's a rough sketch. Okay, ensure that the number of turning points does not exceed 1 less than the degree of the polynomial. So the degree is 3. And there are 2 turning points, 1, 2. So we're okay there. Alright, so then you can graph it. Here we go. Using technology, which we wished they would have allowed us to do from the beginning, right? But no, you're learning a lot about functions by doing it by hand like this. So you can't learn this stuff any other way, really. If you just punch it into a machine, you're not going to learn very much except how to push buttons faster. Alright, so if you want to be a professional button pusher, I guess that's the ticket for you. But if you want to understand this stuff, then you gotta do it by hand sometimes. Okay.